Hello and welcome to today's question of the day from the actual IPMAT Indore 2024 QA MCQ section. Today we'll see a question from geometry which involves a triangle and a circle and area. So it's not a very complicated question. It is based on mensuration. We'll read the question and understand whether we should solve the question in the first go itself, or if it is a lengthy looking question, whether we should attempt it in the second round or whether we should completely skip the question if it appears or if a similar question appears in our paper. So let's go through the question and understand how to go about it. Let ABC be an equilateral triangle with each side of length k. If a circle is drawn with diameter AB, then the area of the portion of the triangle lying inside the circle is. Now, in this question, what I understand is the most important part is to draw the diagram. We should have an equilateral triangle. So we would need an equilateral triangle, and let us name it as A, B and C. And if I try to draw a circle with AB as the diameter, one part would be below the triangle and the other part would be above the triangle. What are we interested in? We need to find the area of the portion of the triangle lying inside the circle. So basically we are interested in the upper half of the circle. It will look something like this. To draw a better diagram, I put some diagrams in the slide itself. So basically the figure would look something like this. This would be the vertex A, vertex B, vertex C, and we have the semicircle on the top. The lower part will not change our answer. We are only interested in the area of triangle within the circle. So that will be in the upper half itself. The side of the triangle is K. So if the side of the triangle is K, this is K, and obviously the center, the midpoint would be the center of the circle also. So this part is the radius, which is 0.5 K. This part would also be 0.5 K. Will this cut the triangle at what point? So we can simply draw that radius. This would be 0.5 K. This radius would also be 0.5 K. Well, someone would say, is it not possible that the entire triangle is within the circle? Well, that would not be possible, because we know that the height of the circle is, or height of an equilateral triangle is √3 by 2 times the side. That is, √3 is 1.73 and divided by 2, that will come out to be somewhere around 0.86 or something. So obviously the height is more than 0.85, whereas 85 times of the K, whereas the radius of the circle is only 0.5 K. So clearly the triangle there will be some part of the triangle which is outside the circle, and hence the diagram would be like this itself. We need to find the areas of these regions: region number 1, region number 2 and region number 3. I think it's fairly easy because I can see that 0.5K, 0.5K, isosceles triangle, plus I know some angles because it is an equilateral triangle, and there is in between a sector of a circle. So this is a triangle, this is a triangle, and there's a sector. If I can add up the areas of these three regions, this is the total area that we would be looking in the question. I don't think this is a very lengthy question. So if I would have drawn the question in the paper, I would have gone for this question. Because in the MCQ section, generally you have 30 questions. You aim to attempt around 20 questions, even if it is on the easier side. So you on an average have 2 minutes for a question. Alright. There will be some easier questions which get solved within a minute also. So the benchmark that I keep for myself is, if I can solve a question within 2 minutes, I should attempt it. And I think I could have calculated the answer to this question within 2 minutes. So I would go about it and go ahead with the solving in the first round itself. If you are not very comfortable with drawing the geometric diagram or visualizing it, or maybe you are not very comfortable calculating the areas of equilateral triangle and such things, in that case maybe you could keep this in your round 2. However, I would suggest that the formulae involved here are basics, so you should know them and you should attempt this question in the first round itself. So what are we calculating here? Let's quickly evaluate the triangle and the sector areas. So what is this triangle? This is 0.5K, this is 0.5K. This angle is 60 degree because equilateral triangle. This is an isosceles triangle, so this angle, the base angles are equal, and obviously the total has to be 180, so the third angle would also be 60. This is an equilateral triangle with the side being 0.5K, and the same goes over here as well. So the region number 1 and 2 are two equilateral triangles whose sides are 0.5K. What else do we have? We have a sector. Now this angle is 60 degree, this angle is 60 degree. The angle in between will also be 60 degree. So in between we have a sector of a circle with angle 60 degree. So one sector and whose theta is 60 degrees. And what is the radius of the circle? 0.5K again. So 0.5K can also be written as K by 2, K by 2. Area of an equilateral triangle is root 3 by 4 A square. So here the total area that we are looking for is two equilateral triangles. So 2 into root 3 by 4, and there would be a K square. K itself, side itself is K by 2. So K by 2 square plus there will be one area of a sector. Area of a sector, the formula is theta upon 360 into pi r square. Theta is 60 divided by 360. I know that is 1 by 6. So I'll quickly write 1 by 6 itself. 60 upon 360 is 1 by 6 into pi, and r square. R again is K by 2. So K by 2 square. Again, if I observe carefully, I want all the options which have K square by 24 or K square by 6. So I'll just see what I'm getting here. Over here there will be a K square by K by 2 the whole square. So that will become K square by 24. So I think I should keep the K square by 24 common outside. So from here, can I see all the numbers have been used up? So there will only be a pi, and obviously there's a plus sign in between. So K square by 24 and a plus pi. I'm sure that the answer is going to be option A, but I'll still verify the initial part, by simplifying. So here we'll have a 2, and basically the area of the two equilateral triangles. So this will be K square by 24 into pi, plus from here we'll have root 3, 2 and 2 square. So there's a 8, root 3 by 8 K square. Okay. Now I want a K square by 24. So what I'll do is I'll multiply by 3 in the denominator and multiply by 3 in the numerator as well. And this part actually becomes, this part also becomes K square by 24. So if I take the K square by 24 out common from both the terms, from the first part I'll have 3 root 3 left, and from the second part I'll simply have a pi left. So 3 root 3 plus pi into K square by 24. Fairly easy and doable in the first go itself. My answer to this question is option A. The answer seemed to be option A midway itself, but I still verified the answer till the end, so that there's no mistake, or there's no silly mistake that I end up doing and get a negative marking here. So I hope this video has helped you understand how to approach the question and how to solve such questions in the exam. I wish you all the best in your IPMAT preparation. Do well and keep working hard. Thank you.